Gallup's divine prediction even inspired the creation of a phenomenal American TV series in recent years, House of Cards. The production company, Netflix USA, utilized data analysis to discover that audiences who enjoyed the 1990 British version of House of Cards also loved Maverick director David Fincher. They were also loyal fans of Oscar-winning actor Kevin Spacey. With strong data analysis support, building up to climatic success, Netflix combined fans of the original House of Cards, Kevin Spacey, and David Fincher to produce the new version, which eventually became a huge hit. After Gallup, another American took up the banner of data sampling technology, crossing oceans to Japan and leading its post-war industrial economy to rapid growth. This legendary figure, who bloomed abroad, was Edwards Deming, known as the father of quality management. Deming, originally a PhD in physics, mastered sampling techniques through census work, later applying statistical methods to corporate quality management with remarkable results. After 282, General MacArthur invited Deming to Japan to promote his quality control methods. At that time, Japanese manufacturing was synonymous with shoddy knockoffs, with entrepreneurs having no concept of precision craftsmanship. Deming told businessmen, "Japanese products will dominate international markets within 5 years." Everyone was stunned, unable to believe it. Deming traveled across Japan, teaching quality control methods, providing hands-on guidance to enterprises. Deming believed over 85% of quality issues stemmed from management-induced deviations. The key to effective quality control lay in mastering data. Deming's arrival made data and charts blossom like flowers throughout Japanese enterprises and factories. His quality control methods included several simple, relatable examples. One was his variance control method. For instance, if a blanket claims 50% wool content, randomly sample 10 1-centimeter circles. 49 to 51% is acceptable. One outlier makes the entire blanket defective. Another example, a Japanese steel company imported raw ore via ships. Previously, they'd randomly scoop one shovel from the ship for iron content testing at the dock. These few shovel scoops only collected surface-level ore, failing to represent the entire batch. Under Deming's guidance, they designed new sampling method, randomly stopping conveyor belts during unloading to collect samples, ensuring whole shipment representation, embodying random sampling philosophy. This method eventually became international standard for bulk material sampling through continuous refinement. Hearing this, you might think Deming's quality methods seem unremarkable, common in modern factories today. But for post-war Japan, rebuilding its industry, controlling product quality to revive economy and exports, people had no conceptual framework or concrete measures. Deming's mature quality systems charted their course. Both Gallup's predictive analytics and Deming's data-driven quality control demonstrate commercial data utilization power. In small data era, human data applications created countless miracles, but limited data collection and processing capabilities severely constrained applications. The big data era fundamentally transformed this landscape. Traditional small data stemmed from measurement, while big data is born from documentation. This documentation manifests as text, images, audio, video, etc. Thus, big data can be understood as traditional small data plus modern massive documentation. Next, we'll explore the rise of big data. This section addresses two questions: big data's origins and its implications for humanity. First, where does big data originate? As early as 1980s, American scientists predicted computing evolution. Mainframes, PCs, wearable micro devices. In final phase, body-worn sensors track and record every meaningful data point, uploading continuously. German soccer club embeds sensors in balls and players' jerseys, knee pads, collecting 60 million data points per match. But coaches can analyze this data to develop new training strategies. In daily life, smartwatches, car sensors, and street cameras constantly collect data. Humanity now possesses capability to massively document physical world status. Everything is data becomes hallmark of big data era. Another defining feature of big data era is data openness or sharing. As time entered 21st century, many remember 2001's 9/11 attacks in US, but few know its connection to data transparency. For extended period post-event, no one could accurately determine the exact daytime population in Twin Towers remained unknown. 100 days later, USA Today estimated 10,000 to 14,000 workers using casualty statistics, then considered most authoritative figure. This significantly differed from final 2005 reports, 17,500 count. The tragedy exposed flaws in national census data systems. Pre 9/11, federal government recognized importance of tracking daytime population. Daytime population refers to working population during business hours. Privacy concerns and legal complexities delayed implementation until September 11th. Accelerated progress. Accelerated progress. By 2006, U.S. government created LEHD-real-time demographic mapping system, integrating employment and residence data. The system anonymizes personal information while tracking macro population movements between workplaces and residences. Crucially, government opened this big data system for public use. This empowered emergency response while benefiting organizations and citizens. The LHED project implementation epitomizes America's data openness history, filled with challenges, but to align with big data era trends and demands, data openness is inevitable. Growing pain for nations. Only by building big data foundations can they reach the data summit. So what exactly is this data summit? Where will the big data era lead humanity? The author here explains the true meaning behind the book title, Data Summit. Imagine a four-layer pyramid. The base layer is data, carrier of information. The second layer is information, data with contextual meaning, source of knowledge. The third layer is knowledge, patterned information forming basis of insights. The summit represents intelligence, machines analyzing data to gain knowledge and solve tasks autonomously. In other words, the pyramid's peak is what we call artificial intelligence today. Human intelligence lies in acquiring or applying knowledge for better living, unlike other animals. General Sherman exemplified this intelligence, synthesizing data or information to make strategic military decisions. Now, machines can learn and apply knowledge like humans to improve our lives. Self-driving cars represent classic AI application. Autonomous vehicles sense environments, analyze data, make real-time decisions and reactions. Their control systems self-learn through accumulated testing experiences. AI applications possess limitless potential. The most efficient AI implementation lies in smart city development. How to build smart cities, what guiding principles should we adopt? The Rat Index story offers insights. Rodent numbers reflect urban sanitation conditions. In 2004, New York City Health Department opened restaurant inspection and complaint data to public. Someone created an application called Neighborhood Rat Index using this open data. They organized rodent sighting data by zip code into visual maps, darker areas indicating severe infestations. The app also listed restaurants with worst sanitation records. Users click map areas to check local rat populations and sanitation conditions across NYC. The Rat Index innovation was fundamentally enabled by open data policies. Government platforms enabling public data access embody crowdsourcing governance principles. Harnessing collective intelligence builds smarter cities. Having covered 230 years of data evolution, let's conclude. How should we interpret this historical journey? What significance does big data hold for humanity? Consider Johannes Gutenberg, 15th century inventor of movable type printing. Pre-Gutenberg, hand-copied manuscripts, limited knowledge dissemination. His invention sparked knowledge reproduction revolution. Mass printing enabled affordable reproduction of all historical knowledge. Similarly, big data history reconstructs human activity through digital documentation. Traditional taxi rides lost time or location data. Modern apps preserve everything. Physical shopping leaves no trace beyond sales. E-commerce tracks every product interaction. Datafied human behavior fertilizes societal progress across domains. Big data isn't some cloud-based mystical technology. It's the real-time documentation of our lived experiences. This concludes our exploration of the Data Summit. Find study notes below the audio. Until tomorrow.